Hello everyone and welcome back to the channel. Today we are fitting joist hangers and I'll show you the hangers that I'm using. It's just some timber to timber long legged hangers, and the aim of what I'm trying to do is you can see that the plate is about 3mm thick, and by the time you've got your twist nail on, which is roughly probably about 2 to 3mm thick, you'll have a step on your timber. So along my ring beam and all my glulam beams that I fitted, what I want is a completely seamless edge. So when I sit my outside wall on and my partitional walls inside sit straight on top, what I want is for it to sit lovely and flush, because the last thing you want to do is, I'll just show you one of the ones that I fitted already. So what I'm doing, I'm just marking up the size of the plates and then just rounding out 6mm deep, just to allow for when my partitional wall goes on there, the sole plate for my wall, it will sit lovely and flush. So you don't want any undulation in the timber. Let's say if I did want to carry my floor all the way through and then sit the wall on top, generally you wouldn't really do that, but I might do that in this case, I'm not quite sure yet. Is you want the floor to go directly over the top, okay, so it follows through seamlessly. You don't want any steps, like let's say like that. You don't want anything like that. So what I'm doing, I'll just show you one now as an example, and then you get the idea of what I'm doing all the way through. So we've already marked up one side of the joist for centres, so all I'm going to do is, the plate on this is 35mm wide, so all I'm going to do is measure 38mm either side and then just square it across. Like that. Mark a little wriggle line on there, and I'm going to use my cordless 1/2 inch Akoki router, set it to the right depth, which it already is set to. You just set it using a stop like that and plunge in it like so, and away we go. Okay, now that that's done, all we need to do next is wrap this up underneath the joist. So let me just lift the camera up a bit so you can see what I'm doing. Okay, so all I'm going to do now is you sit it up underneath there. You got two different flanges. You got one here which will sit underneath my ring beam, so once the joist goes in there, that bit goes underneath the ring beam and holds it up, and then you just nail off all your holes. So like that, simple. Get a twist nail, get it started, make sure it's touching the underside of your ring beam. Which it is, which is good. And now some of you are probably thinking, why am I hand nailing this when you got nail guns which can do it all for you. I think it's called a positive connecting nailer or something like that from Pazload. Now, I would do, but I just don't do enough of these to be able to warrant it because they're 600 quid. I think that's excluding VAT as well. And then you got all your nails on top and your gas, and I'm not sure how much that would cost me. So in the time it's taken me to do all these hangers, I'm probably doing one every 3-4 minutes, and I've got 82, 84 to do. I just didn't see, cost effective wise, it would be warrant for me to get one. So especially when I don't really do a lot of these joist hangers really. If I was doing it every day, then yeah, definitely you'd warrant getting one. And you just wrap it up over the top like that, tap it down. Now I'm trying to make sure it's lovely and square, then it will sit lovely and flat in there. And then you do the same for the wrap over the front edge of the ring beam. So get it lovely and straight, nail it off. So you can see it's quite, once you get into the swing of it, it's quite a quick process. But it is tedious when you've got to do 84 of the buggers. But works work. So just got to crack on with it. Just get into a mindset of repeat, repeat, repeat. Sometimes I like to try and challenge myself. So I did that one in, let's say, 3-4 minutes. Let's say if I can get the next one done in 2 minutes, but I ain't been able to do that yet. Okay guys, so that's it. So that's how you do one joist hanger. So now it's all wrapped up over the top. I'll drop the camera so you can see. And then this will sit lovely and flat. Okay, so when the sole plate sits on there, there's nothing stopping that from riding up. Just need to tap that one a bit more home, and that's it. Look, see? Okay, so now you just got to go all the way through now, mark them all out, router them all, and do all that. And then the next step is to put in all your noggins. We marked out the centres for all these noggins, which help tie all the structure in together. Even though you got these joist hangers across here, it just helps tie it all and give it more strength. So the next step after that was to put in the rows in between. You don't need any on there because the span from there to there is so small that even if I was to jump on it, and I'm a good 18 stone, it doesn't move at all. So, and what I had to do on the end here is, because these joist hangers were so close together and I wanted to get a full wrap around to give it as much strength as possible, because with these joist hangers, all the strength comes from when you wrap up over the top. Okay, so what I measured was from this far end, from here to where the internal face of the wall was going to go, and then mark another 10 millimeters more. I've actually marked it on here, so I'll show you. So this represents the wall, okay, which is a 6-inch wall, and then this represents the 10 millimeter gap. And because you put your flooring opposite to the way the joists are going, so in this case the way that my pencil is going, that's the way that the joists are going to flow. I've gone 600 millimeters off of this gauge line here all the way up to here, and then put in double noggins every 600, just so we pick up each individual bit of floor when it comes through here. You see what I mean? Yeah, so this will be where a 600mm chipboard bit falls, and then there and there and there. It's just for all of our pickups. Okay, so now the next step is to do what's called perimeter noggins, which is to pick up your floor. So now that I know that that is where the start of the chipboard floor is going to go, I'm going to put in some noggins all the way through down to the bottom, and then the same on the perimeter that side. Okay, and then after that, because the wall here is going to finish or start from the end of this ground screw, so it's about 25, it looks like to be about 25mm protruding this way, coming out that way. So the wall is going to be at least 25mm out here, and then it will start to run across here, and then the pickup for the floor will be more than sufficient there. So let's see just what it looks like. I'm going to measure the ground screw that you've just seen. So that is actually 25mm, and there's no other ground screws through there which protrude past. You can see there's just one there and none down the other side. So we know that the wall is 147, so you would just measure on your tape 25mm to the end like that, okay, like this, and then come to 147, which it just falls in between the 50mm space. So if you wanted to, you could put a solid timber order through there, but you won't need to, because you've got a double fixing point here on your ring beam. Yeah, so that space between there and there is more than sufficient, because that will pick up the end of our chipboard sheet, which is perfect. So I'm going to do that all the way around, guys. Yeah, so if you want to, you can just ping a line, a chalk line, from that point there, the reference point, down to there, ping a line and put in your solid block of noggins all the way through, and then do the same down the opposite end. Welcome back everybody to the cottage build here. You can see now I've started to fit the PIR board. I'm using the 100mm just because I'm using 7x2s here, and I just wanted to get as much depth as possible. I could have gone for the 150, but it was just a little bit too much out of the customer's budget, so that's the reason why I'm using that. But also it's just to help stop any transfer between cold and warm air, and then also it creates a sound barrier between. So if you can imagine, if this was like a first floor up, and it would just help the sound transfer between the two floors, so hopefully there's minimal sound going through there as possible. But you can use it in your walls, you can use it in your floors, you use it for when you're building up for screed and things like that. So you'd put like a DPM layer down, and then you put this on top, and then they screed. And you can use this in the rafters, for your roofs, things like that. It's a really, really, really good material. But as you can see, it's a very, very, very dusty, very messy job to do. I would highly recommend you to wear a face mask when you're cutting that stuff. But because we're out in the elements, and it's yeah, I'm not really going to be breathing in a lot of it, but I've got an extraction over on my table saw over there. Now I would use a different type of saw on here, but I haven't actually got one. I've seen one, and it's a Festool one for using for cutting any insulation material, so either PIR stuff, I think PUR, and I'm just using my table saw here just to rip the sheets down to keep them as square as possible. As you imagine trying to cut 100mm Celotex, so the PIR stuff, the stuff that I'm using, with a handsaw, you will typically find that you will not cut it dead true. So this was just a sample piece, so I could show you like how far you could come out of square. So you can see it's miles and miles out of true, nice and 90 degrees to the finished face of the board. So you can imagine if you were putting this inside your joists, inside your rafters, inside your walls, you'll have gaps everywhere. So it's actually because you got cold spots there. So you want it as dead tight as possible, even just a little bit over tight, so you just have to force its way in to its position. So I just thought to myself, I've got an old saw blade in the table saw, so I thought I'll just utilize that and put the extraction on it. And I know I have to flip it up each time because there's the maximum depth on that saw is only 65 millimeters, I believe, and the board is 100 mil, so you have to flip it up and cut it again. But at least if I know this is cutting it dead true or within 1 to 2 millimeters, then I'd rather do that. That I've cut, it's, you know, it's not dead true. You can see it's probably a couple of millimeters out, but it's a lot better than what it would have been if I was hand cutting it. I'm going to be putting it in. It's going to be in this third bay here. So I put in the solid block in there for the floor, so I've got to take a little section out which is the same width as this, but also accommodates for it to sit directly underneath and goes right up to the edge of the ring beam. Otherwise, if you stop it here, there's a cold spot there, and you don't want cold spots in your floor. You want to close the gaps up as much as you possibly can. So we've got from the noggin to that is 1540, and that is right. Let's just see how far out of square I cut this. And with that insulation saw as well, it's got a hose adapter on there, so you can just plug straight into my extractor, and it will get rid of all this dust as well. Now I started off square. Is it square all the way down? Within, but it's on a very narrow part of the board. Can you imagine going down a 2.4 meter run? Right. That's 175, 175. So this is a section I need to take out where that noggin is. So the solid blocking to pick up the floor along the edges. Alright, just make sure it's nice and flat. It is, it's good. There you have it, nice tight fit. And you just go across it axle. There you go, nice tight fit, perfect. And just move on to the next one.